Dear participants, the main of points of the work of the third year students of ShevchenkoNational University of Kyiv on the topic a mapping of morphometric indicators and analysis of relief by GIS on the example of a ravine in Holosiivskyi district of Kyiv. The development of landslide processes depends on many factors. Their activation can be triggered by anthropogenic activities. The analysis of landforms and geomorphological processes is of great importance as they form the basis from human activity, which often leads to the activation of hazards exogenous gemological processes and phenomena. The article investigates the influence of morphometric characteristics of the relief, which affects the amount of moisture in the soil, which is in turn affects the activation of dangerous geological exogenous processes. The object of the study is the site of the territory of Holosiivskyi private ravine in Kyiv, located in the southwest part of Kyiv in Holosiivskyi Park. From the west to the east, the Kyiv ponds with two tributaries stretch where the main channel of the ravine branches. The relief is divided by a small hydrographical network, ravines and gullies. Modern genetic type of relief refers to the modern relief, floodplain, and gully bottoms alluvial deposits. So in the studies, the analysis in Wildwood, the calculate of terrain slopes and water courses as the dimension of runoff accumulation areas as well as SPI and Tsiupa indexes using ArcGIS to analyze the participant associate with the digital elevation model, the hydrographic networks, topographic maps, and where we use to vectorize and build the digital elevation model in ArcGIS software. You can see in this team model. So next. Analyzing the absolved elevation and the builder relief profiles, our object of study is a complexly branched ravine with the length of the main ravine channel existing 600 meters, with several lateral branches existing 315 meters. It's inlaid, most of which coincide with the main channel in their morphometric characteristics, including the institutive development of slope processes. According to the cross-sectional profiles, you can see profile 1 and profile 2. Closer to the center of the branch, we can see that this part of the ravine is the stage of old age, where there is a throat-like profiles type, and other branches have left and right step slopes with a winden bottom. The type of valley development is U-shaped. The cross-section shows V-shaped profiles, which indicates that the ravine is young and continue to develop in this part of the branch. Thus, we can trace the development of the ravine through different stage of development from young to old age. So next. The slope forms were classified according to their slope and catchware in the plane and profile based on the classification. A map was created with 5 classes, less than 2 degrees, representing flat areas, 2 to 5 degrees, representing slightly undulating areas, 5 to 15 degrees, representing gentle slopes, 15 to 35 degrees representing medium slope, and over 35 degrees representing slab slopes. Its terms of steepness, a ravine is classified as steep with a slope rather than 35 degrees, and this you can see in this picture. Depending on the general physical and geological location of the area, the main aspect of the slope are southwest and northwest. So this is you can see in the picture too, the aspect index. Next, the index of susceptibility to linear erosion determines the erosive power of current moisture based on the assumption that the flow rate is proportional to center catchment area. This SPI index shows minimum values for area with topographic significance, potential, and the maximum values for potential erosion area. The highest value are associated with a significant slope, so the lowest value represent relative flood areas, which affect the disability to flooding submission and accumulation. The topographic wetness index, or TVI, depending the influence of topographic on the location and size of certain runoff sources. Based on the values of the topographic wetness index, it's possible to classify it in the categories with reduced areas of moisture accumulation with the appear soil horizon, maximum index values to reduce area of potential water gluing, minimal index values, that wetness accumulation may occur on relative gentle slopes, and erosion proposed may occur on steep slope, and that's the susceptibility to their development increases as indicated by the SPI index. So results in this study we mapped the factors that influence landslide processes and certical the natural geomorphological factors, named the elevation aspect, the slope, the stream power index, and the topographic wetness index, analyzing the relief of the study area and geomorphological characteristics can be obvious a certain pattern. In the further areas, there is a particle on no stability index, no to linear erosion, so to SPI, while to slope index is high, research more than 13 degrees in its area. The TVI maps is completable with the slope map, as steeper slopes have less moisture and respectively. The development of landslide processes is a study area occurs in the preparedness of steep slopes as an aquifer in overburden or water resulting rocks. In the aquifer floods and horrible climate conditions or institute precipitation with in exhaustible by horrible human activity. So, in conclusion, we can say that the obtained map of morphometric indicators can be used for further calculation and calculation of landslide hazard focused maps. The result obtained allowed us to assess the geomorphological precipitation for the development of water-glad lands. Take this factor into account when planning landslide and other moisture, and provide us with additional information about possible floods zones and the development of new potential areas prone to the dangerous exhausting processes. Thank you for your attention. That's all.